0.4. This is the rotation as well, but this is primarily dealing with the construction process of that rotation. But before we get into that, let's understand what's going to happen if we have to rotate a figure around its center. In this case, we're asking to determine the minimum number of degrees that this would have to rotate around itself to be back to exactly how it looks right now. So if I have here this triangle, right, if this is the center, if I was to rotate it upon its center, how many degrees would I have to turn it so that, you know, this first vertex would land on the other vertex, and same thing over here. So the best way to kind of think about this is actually to think about it as an inscribed image. So if I take a second here and have a circle that is in fact inscribing this triangle, I break this circle, which is 360 degrees. So it's 300, oops. Let's use the pen, which is 360 degrees. And we'd divide that into how many equal sections we have. Right now, in this situation, we are dealing with an equilateral triangle, right? So we got an equilateral triangle where all three angles in there are the same, and same thing with the sides. That then breaks up this circle into three equal sections. So that means the 360 degrees has been divided evenly. So in this case, I'm dividing by 3 because there are 3 equal sections in this situation. That also directly corresponds with the triangle. So since it's an equilateral triangle, we divide 360 by the number of sides. That works when we have a regular polygon. So what is a regular polygon? A regular polygon is when all of the sides and the angles are equal in measure, right? Regular polygons. So in this case, we're dealing with a regular triangle, which we call an equilateral triangle. So that 360 divided by 3, that's going to give me 120 degrees. So every time I take this image, and let's see here, if I highlight this, let's see, if I highlight the sides here, if I group them together, if I turn this, again, that would be 90 degrees, not onto itself. If I was to keep going, right, there's 180 degrees, still onto itself. But again, if I went that 120, though I'm not rotating it exactly in the center, there we go, you can see that clearly it lands back exactly how it looks in the first case. So it lands back onto itself, right? So if we take that thing, that shape again, if I rotate it once more, another 120 degrees, I would land again looking exactly like this. So in this situation, right, I am told that I can rotate 120, again, twice, that would be 240, or 3 times, which would be 360. So all of these rotations would get this triangle to land back onto itself. The question here asked for the minimum number. Therefore, I only need to answer or say that it is in fact 120 degrees. I should have my degree symbol there for each of them. All right, so that's the minimum number. Again, they could ask for all of them, the minimum, whatever the situation is, make sure you answer the question appropriately. All right, same thing over here, right? Again, this is a regular pentagon. All the sides, right, are equal in length, along with all of the angles here, right? All of these are equal as well. And again, if you envision this, you don't have to do it, but if you envision it inscribed within a circle, you are then having to talk about all of these segments, these between each vertexes. Each of the vertexes will then, vertices, each of the vertices would then create this arc, which would be equal, right? So that circle has been divided up into an equal amount. So in this case, 360 divided by the number of sides, so in this case 5, and that's going to give me 72 degrees from there. So each one of these things is divided up, and I get 72 degrees for each of them. Now again, the question just asked for a minimum number, so 72 is your answer, right? But if it wanted, more of them, I'd have the list of all of them, that'd be 72, 144. I get 216. Right, that would be 3 times. If I do another 72, that's going to be, what is that, 288, right? Another 72, right? That gets me back to 360. So this would be all of them. Once again, I only care about the minimum one here, the smallest. So again, my final answer in this case is just the 72 degrees, all right? But again, they could have asked for all of them. They could have asked for, the smallest. Sometimes I might even ask for the largest that's not 360, because 360 would just be a full circle. So it could ask for different measurements and different things. All depends on which one. So hopefully that's a good understanding of how we can rotate around the center of these figures. Again, specifically talking about regular polygons in this situation. All right. So the next thing we're going to do is the actual construction here of how we can rotate a thing. So to be honest with you, the fact that we're being asked to rotate around 60 degrees is a little difficult, because we need to use a protractor in order to do that. And in this case, I'm going to allow us to use the protractor here as an example and as a process. But again, on the Regents exam, they're not going to ask you to use the protractor for that. So you're going to have to do it in a different way. We're going to talk later on in a different unit, a little bit of a different process, but I want you to get used to the concept of how to use the compass here and the protractor together. So we're going to create this process, and we're going to actually rotate it 60 degrees. So what we're going to do first is just simply draw a line segment from whichever point we want to rotate. So in this case, I'm going to start with C, and I'm going to draw it to the center of rotation, which in this case is F. So I'm going to take, again, my protractor. Unless you have a process that's going to be able to get you this angle without doing that, I'm going to have to use the protractor. So it's a 60 degrees, right? It's positive 60, so we're going in that counterclockwise direction, right? So I'm going to rotate this around so that, I'm going to rotate this around so that I have the bottom of my protractor is in fact in line with the line segment, in this case CF. For some reason, my protractor here is freaking out on me, so let's give it a minute, see if we can fix that. There we go. All right, so let's rotate this around. We're going to rotate until we get to the protractor to be on CF. And again, we're, for some reason, having an issue here with our protractor, not wanting to cooperate 100% here. So give it a minute. So I'm going to keep rotating here until it lands right on the bottom is with CF. That looks better there. All right, and I'm going to make a mark again on my protractor here. I'm going from the inside portion, so it's here 0. So the inside I'm going to 60. All right, so I'm going to make a little mark here at 60 so that I know exactly where 60 degrees is. All right, so I'm going to take that and now move it. Now using my straight edge, I'm going to connect F and that point there. I can make it a little longer because I'm not quite sure exactly where, the 60 degrees. So now I know that this angle here is in fact 60 degrees. All right, so this angle here is 60 degrees. All right, so now I can actually do the compass work here. So I can take my compass. All right, I can put my pointer on F because that's what we're rotating around. I'm going to measure out to C, right? And I'm going to make an arc from C and see where does that intersect my line segment. I know that this has to go in this direction because I'm going in that counterclockwise direction. So that's my 60 degrees. So that's why I knew that I had to come in this direction here. Right, once I intersect the line segment we already had, I now know that this is going to be C prime. All right, so we're going to basically do that same process for each one of the points. I'm going to use a different color here for each of them so that it's easier to see. So let's see here. Let's do from B now. So let's go B to F. Again, I'm going to line up my protractor here. I want to put this right on the line segment BF. again, as accurately as possible. All right, I'm going to make a mark. Let's see, at 60. I can move my protractor away. And now draw a line segment from F through that point. All right, again, now the red angle is in fact 60 degrees. Take my compass, put it back on F. Going to measure out to B. Again, I'm going from here. Now, if you don't want to draw the entire arc, as long as you show that you measured that, and then I'm going to just turn it and see where does it intersect. It intersects, in fact, right there. So at that spot, that's going to be B prime. And again, I'm going to repeat this process one more time for A. So from A to F, all right, come out here, put my protractor on F. I'm going to rotate around. Again, I'm not quite sure why this is taking so long to process this, but we will deal with it. All right, so I'm going to line this up. Really going out of our way here. All right, let's try getting that back there. Again, as accurately as I possibly can onto that, in this case, that green line that represents the line segment between A and F. Right there. Oops, well, we really are causing a problem here. There we go. Took us long enough, right? So again, 60 degrees, make a mark. I can move my protractor, draw my line segment from F through that point, and then I'm going to make the intersecting arc, again, from F, in this case, to A. Make a mark, rotate around. And again, I just need to show the intersection. I don't have to draw the entire arc, unless you want to, that's fine. And now I know that, in fact, this point here is a prime. So to conclude, I now just need to connect all three of my new points. In this case, I will do it in, let's see here, let's use purple here. So we'll connect A prime, B prime, and C prime. And now I, in fact, have here, and I'm going to color this in just so that it's a little bit easier and clearer to see here. All right, so here I have my new figure, A prime, B prime, C prime, and that's, in fact, after a 60-degree rotation. All right, like I said, realistically speaking, on the region exam itself, this process probably wouldn't be done using the protractor because they're not going to let you use the protractor. So you're not going to be asked to actually do like a 60-degree, but it is a process that you should know how to do. But we'll talk about other options and how to do that in different ways. All right, in another video. But take the opportunity now to pause the video and try this construction on your own, and then come back. All right, so the last thing I want to show you, again, here's one that's a little bit more realistic. I've shown it to you in symbolic form, right? So it's the same image, but just a symbolic written version of how they want us to perform this construction. This is one that is a little bit more realistic for the Regents exam to ask because it's 180 degrees, and that's something that's easy for us to be able to do construction-wise. We don't need a compass in order to do that. I'm sorry, a protractor in order to do that. I just need a compass for this one. All right, but essentially it's a very similar process, just not including the protractor part. So what I'm going to do is I'm going to draw a line segment connecting the point we want to move through the point of the center of rotation, right, from there. Now I'm going to extend that because 180 degrees, right, is going to be on that same line. All right. Now, if it was not 180 degrees, let's say it was something like a 90-degree rotation, I would then want to make a perpendicular bisector that goes through F here so that I would know exactly where 90 degrees was. But for 180, that's just going to be on the same line. So in this case, we have a nice situation because of 180 degrees. All I got to do is just simply measure the distance that F is from A, like so. Again, when I measure that, make a little arc to show that I measured it. I'm now just going to go all the way to the other side and see where does it intersect here. Because again, F would be for 180 degrees. I'm just dealing with something that where F is the midpoint of that. So now I know that this point over here is in fact, oops, let's get the pen out. In fact, this spot right here is now going to be A prime. All right, and we're going to repeat that process for each one of them. So again, using a straight edge, we'll do different colors here to make it a little easier to see. We'll do from C through F there. Again, gonna keep my compass on F. I'm gonna measure the distance it is from C. Make a little arc to show I've measured. I'm gonna flip my compass around, see where does it intersect the other side of the line. Now I know that this point right here is in fact C prime. And last but not least, let's repeat that process one more time. And let's do, we can do green, that's fine. We'll go through F over here. I'll just like make this more accurate. There we go. Again, measuring from F to B. Oops, that's not big enough. That's better. So that shows me that measurement from F to B, and that's going to intersect over here. And that gives me, oops, lost my spot there. That gives me B prime right here. So in this situation, we have now constructed that triangle. Once I connect the points together, again, I'll do this one orange. So now I have, using my straight edge, the connection of all three of these points. And that, in fact, gives me my new shape and new figure. Again, sometimes helps to kind of shade it in there so it's easier to see. All right, that. So that's how we can do it. Again, I did not need a protractor here in order to do this. And that's going to happen for 90, 180, 270. These are all ones that we can easily do without a protractor because we can easily form those angles simply by creating, in this case, a straight line for the 180. If I wanted a 90 degrees or even 270, I just make a perpendicular bisector that goes through that point F, and that would give me 90 degrees in one direction, or 270 is just, again, the same thing as going negative 90 in the opposite direction. So those are ones that we can easily do using just the compass and a straight edge. So these are a little bit more realistic as to what might be on the actual Regents exam. But again, the process of actually being able to do the rotations, with the use of a protractor, you can do any angle that you are asked to do, but from there. So take this opportunity to pause the video and try this on your own in your notepad.